Hello, year 13. Unfortunately, at the end of last term, I managed to catch the flu from somewhere the day that I broke up, and then that turned into a nasty chest infection. So I won't be back to college until Friday with lesson for you. So this one we've still got to get things done before your mock the following week. So it's really important that you do this lesson properly, or you'll not have a clue what's going on in the test. I've got two special review questions here that are really worth you doing. I'd like you to have a pause and have a good go at these two questions, and then we'll just check through the answers. So please pause now. Okay, unpause. Here's the first one. Hopefully you got something similar, whether you did it a different way or not. And they just did that. They've not done it as a matrix, but I think that you can probably get the idea. And if I could see what it looked like before, we usually set them out as a matrix. So I normally, if I just quickly, if in case he's looking at this blank, and I usually write here y equals x, and if y equals x, y equals mx plus c there. And you do whatever it was with the matrix, which must have been 2, 2, and what was the other one? Maybe it was 1, 3, was it? Looking at that. Wish I could see the question. I can't, sorry. Anyway, let's hope you managed to do that. Actually, I'm not sure that it was, so I'll be quiet. But that's the idea, and then you get something else. And hopefully, anyway, you've managed that one. We've done plenty of them before. It was the second one I was really interested in, because it really might be very helpful for your mock to have this special method that I mentioned, whether you took it on board or not, or whether you've been spending about half an hour trying to do it an old-fashioned way, which is fine, but it does take longer. Here's the quicker method. Here is this formula. Learn it. Please learn it for this test. It will really make your life a lot easier. Here it is. The shortest distance, C take A dot B time B cross D over the modulus of B cross D. And that's the answer. So if you didn't get it, or you didn't do it that way, stop this video right now and have a go using this method. Sort of flick back or pause it, hide it, and use that formula and see if you get that answer there. Really do it. It will really benefit your revision. I can't know if I can stress this anymore. Do it. Okay, I'll stop being gruff now. That's to carry on being gruff, but won't be nasty. Let's have a look at what comes up next. So this is a little recap. It's in your booklet. We're on continuous random variable stats. Just a little reminder from AS about variance and mean. If x is a continuous random variable defined by a probability density function little f of x over a to b, the mean, sometimes called the expected value, and variance are given by these formulas. I think I mentioned this right at the end of last year. You cannot find the mean and the variance from the big F. You need the little f. So if you're given the big F in the test, you will need to differentiate it to get little f, and then use one of those two formulas from the formula booklet. Very similar to the discrete one, if you can sort of see the relevance, the connection. E of x is just x squared times f of x, and e of x all squared is that one all squared. It's the same as those two variants of formulas. There is a way of seeing which is, anyway, I'll be quiet again. Standard deviation is the square root of the variance, just to put that one in there. Right, have a go at those two multiple choice questions. Please pause and then I'll bring up the answer. Okay, I'm taking it you've unpaused and had a go. Here are the answers. Oh, a little note, stressing what I said before, if you get big F, you'll have to differentiate to get little f before applying the rules. And there are the answers. Hope you got them. Okay, the new bit today, which is in your booklet, the special case of the rectangular distribution. To be able to prove the mean and variance formula for a rectangular distribution, to recognise a rectangular distribution, to be able to calculate the mean and variance of a rectangular distribution, and to be able to calculate the probability of a rectangular distribution. So a rectangular distribution, sometimes known as a uniform distribution, is a distribution that has a constant probability. Here it is. It's different to a dice being discrete, where each number is which probability is the same. It's different because it's continuous data, but the same sort of idea. So everything in the range from A to B has the same probability, and they'll add up to 1. If that means that the area there would be equal to 1, so using that fact, this line y must be whatever the height of this rectangle is. Now if it equals 1, we know that the area, that means that length between A and B must be B take A. This length here. Times something must equal 1. Well, that something has got to be 1 over B minus A. So that's the height here. And that's what that line must be then. And that leads us to the rectangular distribution PDF. Since f of x is symmetrical about the median and in fact the mean, e of x, they will both be equal to whatever that is in the middle. What do you think that is? It's halfway between A and B, so that'd be A plus B divided by 2. So it's good enough to know that the mean, and the median in fact, will be a half of A plus B. for rectangular distribution, which is uniform continuous. Proof of the variance formula. Now, I'm not sure I put one on the homeworks, so you might not be able to recall the video. You might want to pause this video right now, having a look at this formula here, and try and prove it with the graph, knowing what f of x is 1 over b minus a. Or you might just want to watch me and learn how to do it, because you never know, it could appear. It's appeared twice on papers in the past to prove this, so it's quite a regular one they put on as a stats proof. But let's have a go together, if you're not brave enough to stop and do it on your own. So let me just refresh my own memory, squeezing it in. So it's the integral. Because we've proved the mean before, so we're just going to accept that that's minus a plus b over 2 whole squared. I'm not talking too much, sorry. I'm still here. Right, and then put the limits in. Now this is where we need knowledge of this thing. Might not be that common knowledge to you, but learn it now. Something you need to know. The difference of two cubes is b minus a bracket b squared plus ab plus a squared. You can't do this proof not knowing it, or it'd take too long to do a long. You could do a long division to see how many times that went into that if you wanted, but if you can remember the proof, it'd be better. So using this thing here now, this b cubed minus a cubed, the b minus a will disappear, cross off with the 1 on the bottom, and we'll be left with if you like, and put a bracket around that, and put them over a common denominator of 12. And then on the next sheet I'll just cancel some of that down, and we'll be left with, oh, and hopefully that's a well-known one enough for you to realise that that is in fact b minus a all squared over 12. And that's the major formula that you will see. I think it's in the formula booklet for you. Just have a little check there if I can find the booklet. Here's a booklet, see if it's in here for you. Oh, no it's not. Is it? No. No. Used to be. Taking it out. So you'll have to learn that one. So for continuous data, the mean is always half of a plus b, and the variance is a 12th of b minus a all squared. So sometimes they make you prove such a thing, or slight different proof by putting the odd number in or different letters. And then they maybe ask you to use it. When you're using it, it's just dead easy. And there's a thing, the formulas are not given in the formula booklet. There we go. And there's the proof. Again, in case you were doing it yourself. Never mind, there it is again. Oh, and again. Wonderful. Seen it twice, we won't forget it, will we, folks? Right, the cumulative distribution for a rectangle distribution will look like this. Again, you see no probabilities, running total of probabilities, nothing till you get to A, and then the running total probability stacks up till it gets to 1 and stays at 1. If you remember how we get the big F from the little f, all we do is we integrate it between its two between the bottom limit and a variable limit x. Bottom limit being a, variable being x. So let's have a go here. Little f of x is 1 over b minus a. Keep b minus a in this time. Will give us that thing. And that's the formula for the big F of x. And there it is in a nice little box. But honestly, I wouldn't bother learning that. I'd just deal with it when you see a question and integrate it. Integrate little f of x, whatever it is, in the question. But you could use that if you really wanted to, but it's weird. And I keep reminding myself that that's not really there, that's just what the computer wanted to put on. Right, then let's have a look at how easy these questions are if you don't need to do any mathematical proofs. A continuous random variable x has a rectangular distribution on the interval 0 to 3. Calculate the PDF, the CDF and the standard deviation and those other two things. So PDF first. Draw a picture. Oh, that's not naught, is it? That's naught. I'll put 3 up here. Rectangle. Can we all draw a rectangle? Mine's a bit squiffy, but it's not too bad. So knowing the area of that must be 1, that means that this must be a third. 1 over 3 minus 0. and 0 otherwise. Part B then, find the big f of x. That's when we integrate little f of x. I'm not going to use that formula we met before because it's just a bit daft. Bottom limit 0, variant factor x. So big F of x. Zero up to the bottom limit. X over 3, 4, 0 to 3. 1 after x greater than or equal to 3. Test it works, you put 0 in, you get 0, put 3 in, you get 1. Wow. Next part, standard deviation. So we use our little formula now. Standard, because it's a continuous, this is a rectangle distribution, so we know the variance, we've just done it. So work that out. 3 take nothing, 3 squared is 9, so that would be the variance. So the standard deviation is the square root of that. 3 over root 12, 2 root 3. And yes, you can get rid of the third on the bottom if you like. Top and bottom by root 3. Oops, 6, and that would even cancel down further, wouldn't it? Then it'd just be, oops, root 3 over 2. Lovely. Right, a bit more then. Part D, find the probability x is less than 2. Well, you'll like this one. Draw the picture, in fact, again. So we're finding the probability it's less than 2. Less than 2 or less than or equal to 2. No difference between those two questions, remember, because actually the probability x equaling 2 is the area of a hair, which is 0. So that would be the same, just to enhance that. Those two are the same question. And the answer, the area, well, it's the area of a rectangle. I think that's the easiest thing to do. 2 times a third is 2/3. Yippee. Now this one, probability x is less than mu, take sigma. Well, we know what sigma is, that's a standard deviation. We've got that. That was root 3 over 2. Mu, remember, is a plus b divided by 2, which is the mean e of x, whatever you want to think of it, and that's 0 plus 3. So this question is actually asking, let's put our probability that x is less than 3 over 2 minus root 3 over 2. So that. So you can do another picture if you like. It's the same picture. That must be 3 over 2. Take, oh, You can do this as a decimal if you preferred, I think, but we'll keep it as exact. We're after less than, yeah. So all we have to do is that length, which will be 3 minus root 3 over 2 times the height of the rectangle, a third. And then that gives us that over 6. I'll leave it all over 6. Lovely. If you did it as a decimal, I think it comes to about 0.0918. Sometimes they just like things to 3 significant figures. And that thing there is 0.257. I don't know if I said that rounding, 275. Right, here's a whiteboard questions for you to do. Have a go at these and take care that the bottom limit is not 0. So now please pause the video and have a go at those. Okay, unpaused now. Here are answers. Have you got them? Make sure you've got, on the little f of x, you've got the bracket and the otherwise business. Big F of x, you've got the 0, the 1 at the end and the function in the middle. As I said, bottom limit isn't 0, so you would have had a minus a quarter. Standard deviation, the square root of a 12th of b minus a business. There it came, that. And you could have done that with a get rid of the square root on the bottom if you preferred, which I'm sure you did. And there's the second part of the question. I just did it as a decimal. You might have done it as a more exact. Oops, says complete worksheet. Put your final answers on whiteboard for checking, slide 1 only. Oh, I'm not going to check them. You're going to have to check it yourself. Let me just get on with this last little question here, I think. So example 2, the rounding error. Sometimes they like a story. So this story is about the rounding error made when measuring the lengths of metal rods. To the nearest millimetre is the random variable E. What is the distribution of E, and find its mean and variance? So if you think, when you're measuring, well, if you're ever measuring, you're going to be, what's your error can be? Let me just have a read this for you. Suppose we have recorded a length of 75 millimetres to the nearest millimetre. Now the true length could have been any length in the interval 74.5 up to 75.5, not included, but yeah, 49999999999 if you prefer. So basically that's just get your mind thinking. The error could be anywhere in the interval from under 0.5 to over 0.5. And so you could have your little PDF of minus 0.5 up to 0.5. And what's the height of the rectangle? I think you'll agree with me that could be 1. So this is error. Let's put E in that thing. Right, so what did he want me to do? What's the distribution of E? So the distribution of E is 1, or this is a bit silly, but it's 1 over B minus A. Minus a half gives me 1 over 1, which is 1, which we knew because we see the height of the rectangle. So our f of E equals 1 for between the limits minus a half to a half. Put big E, I don't know, big E, little E, and 0 otherwise. Should be another little that thing, and it should be in little e, shouldn't it? Not like little e. Right, and then it says what's the mean? Well, it's halfway between. Through symmetry, you should be able to see what's in the middle of minus a half and a half. If you don't, I don't fancy your chances in this mock. Symmetry 0. But if you really have to write a half of 0. Or minus A plus B, you can do. And the other one, the formula, a 12th of B minus A whole squared. Well, that's going to be 1, isn't minus 1 squared? It's 1, 1, so that's a 12th. And that's the end of it. Right, there's a worksheet now with questions 1, exam questions 1 and 2 on. Try them and then try exercise 4H, questions 1 to 6, with extension question 7. Those are in your textbook. The worksheet answers are about to appear now, but you'll have to go to your textbook to see questions 1 to 6 and mark them from there. So pause now for the worksheet, and then here come the answers, so you're now unpausing after trying the worksheet. It's a bit weird. And the other bits, question 2. Right, anyway, I hope you enjoyed those and you understand the answers. And just to summarise, for a continuous random variable that's uniform or rectangular, both mean the same thing, then the mean is that and the variance is that. Get a tattoo or just memorise them, it's your choice, but make sure you do or I'll be very disappointed. Anyway, I shall hopefully see you this Friday and hopefully I can talk and I'm not too husky with you. Hope you're all okay and had a lovely Christmas and New Year. Well, better than mine, I'm sure. Okay, see you Friday. Bye bye. Or homework. I can't well, let's just say you know you're going to revise. That's basically what it is for next week. Revise and just do those questions I've just set. You must do the questions I've been setting because this stuff is on the mock. Okay, bye bye folks.